So here the condition is that these two sequences, their terms must be identical, meaning we need to identify those. And the n values will be different for these two sequences. And if I use n1 for the first one, the condition would be 46 plus 8n1 is equal to 98 plus 4n2. So what I'm really trying to do is to find a relationship between these two positions of these in the sequences where they are identical, and then figure out a pattern for those values. So I'll start to simplify this. So that becomes 52, and then I divide both sides by 4. So that would be 2n1, 13 plus n2. So I'll isolate n2, that's easier. And so I can generate a table here to figure out for what pairs these two have identical values. Now you'll notice both n1 and n2 have to be positive. So the least value, where the first time it will happen, where n1 needs to be 7, because then it would be 2 times 7, 14 minus 13 is 1. So that would be 7, n2 would be 1. And if you want to see what those values are, we can use a sub n1 would be 46 plus 8 times 7. So that's 47 plus 56, 102. And in case of the other sequence, because the n2 value would be 1, that would be 98 plus 4 times 1. And you'll see that they are both identical. So that's the first value. And so we need to generate those values. Of course, we don't have to write all of them, but see a pattern. And the key thing is n needs to be less than or equal to 100. So if we extend this, the next value would be 8, and then this would be 16 minus 13 is 3, 9, and 5. And you'll see that the delta here is 1. I'm incrementing it by 1, and here it's changing by 2. And that's because here, that's kind of the slope here, 2 here. So you can just generate this 10, 11, this will go on, 7, 9. And then we just need this to be one of these values, n here, has to be less than 100. So for example, if I roughly guess, let's say this is n1 is 50, then n2 would be 100 minus 13, which is 87. So I can go higher here, because I'm also limited by this not exceeding 100 because of that constraint here. So if I go 56, double that here, that would be 112 minus 13 is 99. So that's as far as I'll go. So this would give us this value of n1 would give us the highest value of the sequence for this first one, the a sub n. And so these n values will give us all the terms. You can use either one, but I'll use that one, which means we're looking for a7, a8, a9, all the way to a56. And we need to add these up. That's the question, the sum. So the first term, as I just computed, is 102. And the next one would be 8 more, 110, so on and so forth. And I can directly calculate A56, which would be 46 plus 8 times 56. Again, you can use a calculator here. Actually, I'm going to leave it in that form. And in fact, I should do this as just to reduce the computation, 8 times 7. So that's my first term. That's my last term. I need to add them. And here, the average, we'll use this property of the arithmetic sequences, that the average is the average of the first and last term. So divide this by 2. That would become 46 plus, because I have 2 of these, plus if I factor out 8, then 56 plus 7, 63 divided by 2, 4. So it doesn't matter. You could have just computed these terms, but I'm just trying to save some time here. 252 plus 46. So 298 is the average of all these terms. Now, how many terms do we have? We're going from 7 to 56, so it will be 56. Last minus first plus 1. So that would be 50. So the sum here would be number of terms times the average. So 298 times 50. So that would become 14,900, and the answer is choice D.